For these problems, we're defining the congruence modulo 4 relation S from the set of integers to the set of integers. For all integers m and n, if we know that MSN, that's the same thing as saying that 4 divides m minus n. So 4 goes into the difference of those two numbers, means that MSN. So we're working with congruence modulo 4. And what this means is that two elements are in the same equivalence class if they both give the same remainder when divided by 4. So that's all we're saying here. So the question for A is 2S7. So what I'm looking for here is what is 7 minus 2, and that gives me a 5. So 5 is not 4, and 4 doesn't divide 5. So it doesn't have to be 4, but it would have to be a multiple of 4. So we would say that 2 does not S7. And that's my answer for that one. Or just no. All right. In B, it says, is 27, 30 an element of S? This is the same thing as asking, is 27 S30? Now, we're looking at two numbers, and we're looking to see if this relationship holds in our definition. So what I'll do is, again, take the two values, and I get a 3 this time, still not 4. So my answer is no. 27 does not S30. Okay. Now, in part C, it says to list 5 integers n such that n S3. So what we mean by this is that 3 minus n, or n minus 3, whichever order, doesn't really matter, that we have 4 divides that quantity. Okay? So I need to have a separation of 4 between 3 and n. So if I go 4 higher than 3, that gives me n equals 7. So there's one value we can use. So can we say that 4 divides the expression 3 minus 7? And certainly, because this is just a negative 4, does 4 divide negative 4? Yes, of course. So there's one value down. Now I can take 4 divides 3, n, and now I can plug in, say, 4 more than 7. Let's go with 11, see how that works out. So does 4 divide 3, 11? And the answer to that is yes as well. So that means that n is equal to 11, or could be equal to 11. Now we have two values of n. And what I can do is just keep doing that, and I'm just going to keep adding 4 to each subsequent possibility. And so then my answer list is 7, 11, 15, 19, and 23. Now, do I have to actually check in on 15, 19, and 23? I don't. I can see that I have a pattern here, and I know I'm working with congruence modulo n, which means that the difference between any pair of values is going to be 4 or a multiple of 4. So those are all good. That's the answer for that.